Hello everyone, welcome to my YouTube channel again. And today we will again continue our learning on the numeric data type in the Python playlist. So, we already covered about the memory allocation of the different numeric data type in float complex. We also understood how to define that. Today we will try to see how to convert this from one to another. Let's say how we can convert int to float or float to int or complex. So that conversion we will see, and what of these conversions are allowed, which of these conversions are not allowed, what are some of the edge cases which can be asked in interview. So we'll try to see that, and what are the different types of conversions as well. So let's try to understand that first, the different types of conversion. So here you can see the first conversion type is implicit widening. So, okay, let me. Yeah, so the implicit widening I was talking about, this is one thing where we can read through the definition. Let's try to understand from that. When mixing types in mathematical operation, Python automatically converts the narrower type to the broader type. So narrower, you can say like this is my int, this is my float, and this is my complex. So in int we can write just 3, but in float we have to write 3.0, and in complex we have to write 3 plus 3j. Even we can write zero point 0 also. So you can see it keeps on increasing as we move this side, right? So it's easier to move from here to here and here to here. And that's what it's trying to say, that it's widening, right? This is just single digit. This is around three kind of digit, one, two, three. And here it's like more than seven or eight digits, right? So something like the count if we just see. So that's how it's getting broadening. So this we can easily do to keep the precision in the values. And this is how, like, this implicit widening method is there to convert the data types when we are just doing some mathematical operations like adding or subtracting. So that is one method. Now coming to the second method, which is explicit casting. So it is one of the forceful method, you can say, where we specifically cast the values from one to other data type using constructor. So here you can see use constructor to force a specific type. Note the casting a float to an int will truncate or chop off the decimal digits entirely. Okay. So let's try to now understand it by implementing these and see how or what are the some challenges that you observe while doing this. So yeah, let's try to implement the implicit widening first. So as we mentioned, we can use the mathematical operation. So we are adding these two numbers and we should see what's the outcome that is getting generated. So it should be a float because it should increase, right? Widened. So you can see it got converted from int to float. Now, if we just uh, add here kind of complex number, what will happen? Let's see. 1 plus 3j. You can see now it got converted into complex also. If I remove this, then 6. It's working. Now, if I have to still keep it removed, but if I add decimal here, let's see what is happening. Still, it's coming as integer. So I don't see it's coming as decimal. Okay, I think this is going to be integer only. So yeah, we can test and try, but overall, like we can see the values are getting changed, right? So yeah, this is one of the tests we have done where we try to implement the implicit widening. Now let's try to uh, see if we can do one more check here. That is, can we remove it from a complex number to a decimal number by using this. Let's say I type just 3j. Then the result should be a number, right? Integer only. Let's see. No, it's not an integer. It's still a complex number. So this is what I was trying to prove. So it gives me this result, which is a complex only. So once we added complex, it can't be come back to uh, int or float directly without using the constructor. So let's try to use constructor now and change it again. So if it is a decimal number, can we convert it to integer? So for that, we have this int, int constructor. Here you can see it's considering the base as 10. So by base 10, it means nothing but the values from 0 to 9, which is like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So all these counts are nothing but 10. So that's why it's considered as base 10. And generally, like human develop this index. So we have 5 fingers, and based on that, we calculate all these numbers. And we have this like based on the prime number 2 into 5. So most of the values you can see are like coming in that good decimal range. So for example, I just try to if I try to divide 1 by 1 or 1 by 2 or 1 by 3 or 1 by 4 or 1 by 5 or 1 by 6 or 1 by 7 or 1 by 8 or 1 by 9 or 1 by 10. Just trying to explain like why we have this kind of 10 uh, ways. So this is again based on like the index fingers, the finger count we have, and also the other reasoning is like if we divide it, if we divide one by these numbers, we will see like how the values are coming. For example, one by one will be 1.0, two by one will be 0.5, three by one will be 0.333, something like that. This is 0.25. This is 0.2. This is again 0. What 167 something like that 66 7 is again some other number will come for 8 it will be like 0.125 something like that, and this again will come some number around 0.111 something, and this will be zero point 0.1. So you can see how many are very fixed numbers we are getting. So 1 2 then 3 4 5, 6. So 6 out of 10 values are coming very round figure. Like we have a fixed decimal place to which we are able to calculate these values. So that's why it's easier. And if we would have gone for 3 or 6 or 7 as a factor, I think for that we may need a different count. Instead of base 10, we might need 12, where we would have done 3 into 4 something, 3 into 2 or something like this. So that's why like we have this 10 as base, and yeah, integer is getting calculated based on that. So yeah, I deviated a bit from the topic, but let's just take it to it. So now here I just use this int constructor to convert it, and you can see it's written base 10 as integer. Convert a number or string into an integer or return 0 if argument are given. So let's try to run this directly and see the output. So if I am running it, it will chop up to 5, right? And if I don't pass any value, then the result will be 0, right? So if as it is mentioned in the definition. Similarly for float also. So if I don't give anything, it will be 0 0.0. And if I give some integer value like 5, it will be 5.0 automatically. If we give this, then this much. Now, if we may want to make it a complex, then I have to pass complex here, and then this will make it complex with 0 as imaginary axis. And if we don't pass anything, I think it will initiate it with 0 0. Yeah. Now, these are some of the tests that we did on how to use constructor to convert these values. And yeah, let's try to run it and see the value that got generated. So 2 int will be 5, which we already saw. 2 float will be 10.0, which we already saw again. And 2 complex will be 4 plus 0j. Yeah. But I think we can't convert this uh, complex, like let's try to do that, 0j, and see if it gives error or not. Yeah, it is giving error. We can't do it, not even integer. So this is not allowed. So yeah, this is like explicit constructor based casting. So we have seen both of these now. Now let's try to understand the difference between this truncating and rounding. So here I have written it. So let's say we have a number 5.99 and minus 5.99. So if I try to make it on the line chart, let's say this is my 0, this is my minus 6, and this is my minus 5. Then this number will be somewhere around this, minus 5.99. And similarly, if this is my 5 and this is my 6, the number will be somewhere around this. So you can see it is close to this. So this number should be round off to 6 in this case. And this number should have been round off to minus 6, right? This is what we are expecting. But if we use int, it's not doing that. It's just chopping it off and it's returning the remaining values. So if you want it to round it as per this line or is this axis closure y, which we generally do using round function. So we have to use the round function to do that. So here you can see the expected output. Now let's try to run and print these values and see how the outcomes are coming. So this is one of the edge case, and many of you might not be aware about it unless you face this issue. So that's why I thought to highlight it here. So you can see 5 and minus 5 is coming here, which I said like here it's this one is coming and here this is coming, which is very far from 5.99. But if we are using rounding, then it's taking the right value 6 and minus 6. Okay. Now there is one more condition that I have added, which is like it moves to the nearest whole number this round, but it is also having a kind of selection criteria in case of conflict, which is like it will go to the nearest even number, not to the nearest odd number. So when such scenario can arise, let's say, uh, so this we already saw, it will give an error. So just run it and show it. So yeah. Yeah, so let's continue on this nearest even number thing. So if I try to round 2.5 and 3.5, so let's again try to make the scale. Let's say this is my 0, this is my 1, this is my 2, this is my 3, and this is my 4. And this is 2.5, and this is 3.5. Now, if I round this, where this should go? This side or this side? Because it's in the middle, right? So whether it should be chopped off, this should be chopped off and it becomes 3, or whether it should be rounded off to 4. So that confusion will be there always, right? And similarly for this also, where it should go, this or this. So it's a kind of convention that Python follows, that it will always bring it closer to the even number. So closest even, like if we compare 2 and 3, which is even number, both are at the same distance, 0.5 and 0.5, but which is even number, this. So 2.5 will become 2, and similarly 3.5 will become 4, because this is the closest even number, although both distance are same, 0.5 0.5, but the even number will be given preference. And that's what let's try to run and see. See, 2.5 is rounded to 2 and 3.5 is rounded to 4. So these are some of the common mistakes that anyone can do unless they are fully aware of these. So that's where I thought to cover it. Yeah, so this is all I think I wanted to cover in this video. So we learned about these type conversions using both implicit and explicit method, and we also saw the different kind of truncation and rounding challenge that can arise if we are not aware about this scenario. So hope you learned something, and let me know if there is any feedback for me. And with that, so I would like to also talk about the next video, which is like I will be coming up on the complex or advanced theories, and yeah, we'll talk about advanced thing around this numeric data type. So with that, I would like to close this video and thank you. Like, subscribe, and share.